Okay, so today we're going to talk about arithmetic or arithmetic sequences and what they mean and how to find them. Okay, so remember that a sequence is a sum of a series. A series is a sum of a sequence. So arithmetic sequence is a very particular sequence. So we're going to talk about arithmetic series in just a minute. And so remember, a series is a sum of a sequence, and an arithmetic sequence is a sequence in which the difference between any two terms is constant. So an arithmetic sequence is a sequence in which the difference between any two terms is constant. So remember, again, as a reminder, during the video, if you need to stop and pause, you can do that. At any point you need to do that, okay? So the common difference is the numerical difference between two terms. And we use the variable, the lowercase d, for common difference. So common difference is the numerical difference between two terms. Okay. So in our examples, it says determine whether the sequence is arithmetic or not. If yes, identify the common difference and give the next three terms. Okay, so common difference means I'm either adding or subtracting the same number every single time. So the difference in 5 and 8 is 3, plus 3, plus 3, plus 3. So this is definitely arithmetic, and my common difference is plus 3. The next three terms, 17 plus 3, 20, plus 3, plus 3. So number 2, 23 to 16 is minus 7. 16 to 9 is minus 7, minus 7, minus 7. So it is arithmetic, and my difference is a negative 7. And negative 5 plus a negative 7 is negative 12. Plus a negative 7 is negative 19. Plus a negative 7 is negative 26. Number 3. So we have a common difference, plus 1, but then it's plus 2, plus 3. So this is not arithmetic. Number 4. So plus a negative 2, plus a negative 2, plus a negative 2, plus a negative 2. So yes, my common difference would be negative 2. The next three terms, 16, negative 18, and negative 20. Number 5. So plus 10, but not plus 10. So this is a no. Now there may be a pattern, but to be arithmetic, it has to be a specific pattern. So plus or minus a constant number. Number 6, what do you think? It is, and the common difference is a positive 12. So my next three terms, plus 12, plus 12, plus 12. Okay, so there is a formula. The nth term of any arithmetic sequence can be found using a very specific formula. A sub n, it's an explicit formula, is the common difference times n minus 1 plus the first term, where a sub 1 is, again, the first term, and D is the common difference. Okay, so to write the equation, we just have to gather the information. So we have a sub n is equal to d times n minus 1 plus a sub 1. So the first easiest piece of information to gather is the first term. First term is clearly negative 5. So to find a sub 24, that means n is 24, a sub n, 24. So the last thing I need is to find my common difference. So how do I get from negative 5 to negative 1 to positive 3 to positive 7? Add positive 4. So we have a sub n is equal to the common difference times n minus 1 plus the first term. So first, write the rule. So it's very important that you read the instructions. The rule is part of your answer, and then the indicated term is part of your answer. So we need to write the rule first. So a sub n is equal to 4n minus 4 minus 5. So a sub n is equal to 4n minus 9. So that's my rule. And then if I want to find a sub 24, that would be 4 times 24 minus 9. Which is 87. Okay, so same scenario for number 8. A sub 1 is the first term, 20. We know our a sub n. We'll get to that when we find our term. The other thing we need to write our rule is our common difference. So what is the common difference? Minus 9, a negative 9, adding a negative 9, right? So we have a sub n is equal to negative 9 times n minus 1. So remember, we have to write our rule first, plus 20. So a sub n is equal to negative 9n plus 9 plus 20. So a sub n is equal to negative 9n plus 29. So this is our rule. And then if we want to find a sub 15, we just plug in an explicit form. So a sub 15 is equal to negative 9 times 15 plus 29, which is negative 106. So let's look at number 10. Number 9 is pretty similar. Number 10, the common difference is a little bit different. So a sub 1 is equal to the first term. But as you can see, my common difference is obviously something a little off. It's not just a whole number, which is fine. We just need to know what the difference is. So you can do 9.5 minus 8, and you get that the common difference is 1.5. It's always the second term minus the first will give you the common difference, okay? So my rule first, a sub n is equal to my common difference, 1.5 times n minus 1 plus my first term. So I have 1.5n minus 1.5 plus 8. So my rule, a sub n is equal to 1.5n plus 6.5. And if I want to find the 48th term, that would be a sub 48 is equal to 1.5 times 48 plus 6.5. So a sub 48 is equal to 78.5. Okay. All right, so let's look at the next set. So this is a little different because they don't give us the sequence, they give us pieces of information about the sequence. Okay, so it says if the given terms are part of the arithmetic sequence, write a rule for the sequence and then find a sub 12. So we have a sub 1. The problem is we need the common difference. Okay, well, we can go ahead and sub into the rule because we have this piece of information. So remember, a sub n is equal to d times n minus 1 plus a sub 1. Well, I have a sub n is equal to negative 7. My common difference is what I'm looking for. If a sub n is equal to negative 7, then my n is equal to 3. And my first term was given as 3 as well. So I have negative 7 is equal to d times 2 plus 3. And it's just a matter of solving. So you have negative 10 is equal to 2d. So negative 5 is equal to my common difference. So now I can write my rule. So a sub n is equal to negative 5, n minus 1 plus 3. So a sub n is equal to negative 5n plus 5 plus 3. So a sub n is equal to negative 5n plus 8. So then a sub 12 would be negative 5 times 12 plus 8. So a sub 12 is equal to negative 52. Okay, so same thing with the next problem. We are given a sub 1, and then this is a sub n. So a sub n is equal to my common difference times n minus 1 plus a sub 1. So a sub n is equal to 6, my common difference. My n, if my term value is 6, then my term number is 24 minus 1 plus my first term. So I have 6 is equal to 24d. Oh, sorry. 23d minus 17. So then we're going to solve. So my common difference is 1. So I have my rule. So a sub n is equal to 1 times n minus 1 minus 17. So a sub n is equal to n minus 18. And if I want to find a sub 12, is negative 6. Okay? Okay, so then we have arithmetic series. So arithmetic series is a little bit better than the others because it has a very specific formula that you use every time. So remember that a series is the sum of a sequence. When finding the sum of an arithmetic series, you use a very particular formula, S sub n. This only works with arithmetic, so don't try and backtrack to what we were doing before and apply arithmetic because it's not going to work. It has to specifically be an arithmetic sequence to find, to use this formula to find the series. Okay, so S sub n is equal to n times a sub 1 plus a sub n over 2, where n is the number of terms, a sub 1 is the first term, and a sub n is the last term. Okay. Okay. So we start out with those partial sums again. It tells me exactly what it wants me to sum. So the first thing is I need to know what, remember I have to have a sub 1 for my formula, which is given to me, which is 2. I have to have a sub n, which I don't have, and I have to have n, which I do have because it tells me to sum the first 10 terms. So there's 10 terms. So I need to find a sub n. So that's going to be a sub 10 is equal to, my common difference is obviously 2, 2, 4, 6, 8, times 10 minus 1 plus the first term. So a sub 10 is equal to 2 times 9 plus 2. So my a sub n, my a sub 10 is equal to 20. Okay, so that means I have s sub 10, because that's how many terms I'm summing. So my formula, I know you can see it on your page, but okay, so is equal to n, which is 10 times my first term plus my last term divided by 2. So s sub 10 is equal to 22 divided by 2 is 11. So s sub 10 is equal to 110. Okay, so a sub 1 is given. It's negative 6. My number of terms is 8 because it tells me to sum the first 8 terms. So then I need a sub 8, which is a sub n. So my common difference, how do I get from negative 6 to negative 19 and then from negative 19 to negative 32? Negative 13, 8 minus 1 plus my first term. So a sub 8 is equal to negative 13 times 7 minus 6. So a sub 8 is negative 97. So s sub 8 is equal to n, which is my number of terms, 8, times my first term plus my last term, all divided by 2. Which is negative 412. Okay, so now we jump to the sigma notation. So the first one's pretty straightforward. We need to find a sub 1, which means my first term, so I'm going to plug in 1. So 6 times 1, because this says that's where I'm starting, is 1 minus 4. So a sub 1 is equal to 2. A sub n, which is my last term, which would be 12. So 6 times 12 minus 4, and I know that because it says it right here. So a sub n is going to be equal to 72 minus 4, which is 68. And n is my number of terms, so if I start at 1 and I go to 12, that's 12 terms. So I have s sub n is equal to n, which is 12, times my first term plus my last term divided by 2. Well, it's 12. So s sub 12 is equal to 12 times 70 divided by 2 is 35. So s sub 12 is equal to 12 times 35, which is 420. So let's put a big star right here, okay? Because this one is different, and this is going to be the one that trips you up. Now the problem with this one is notice it does not start at 1. So my first term, I'm not going to plug in 1. I'm going to plug in 8. So I have negative 2 times 8 plus 3, because that's where it tells me to start. So my first term value is where I plug in 8. So I have a sub 1 is equal to negative 16 plus 3 is negative 13. Now here's the really tricky part. How many terms are there? Okay, so this can get a little tiresome if you try and count this on your fingers. So if you go 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, it gets a little cumbersome because if those numbers get farther apart, it can become much more difficult. But there's a way to do it. You can do the top minus the bottom plus 1. So 17 minus 8 plus 1 is 10. There are 10 terms, and you can count that on your fingers to double check. But I know the difference between them is 9, but there are 10 terms. If you start with 8 and end with 17, that's 10 terms. So that means that I'm looking for a sub 10, which is where I plug in the last term number, which is 17. So negative 2 times 17 plus 3 is equal to negative 31. So my S sub 10 is equal to 10 times my first term plus my last term divided by 2. So S sub 10 is equal to 10, 44, negative 22. So S sub 10 is negative 220. Okay. So for homework on page 5, I want you to do 1, 2, 6, 7, 12, 16, 19, and 20. Okay? On page 5, 1, 2, 6, 7, 12, 16, 19, and 20.